We're beginning our discussion of what's called optimization. Now, optimization is really nothing that you haven't already been doing before. When we're talking about optimizing, we're talking about the maximum or the minimum of some function. Okay, so you've already probably talked about minima, maxima, extrema, really in general. So what you're doing here in an optimization problem is you're using this concept of the derivative and the first derivative test to choose or pick numbers that satisfy some given equation that are maximal or minimal. Now, in this case, we've got two examples that deal with, some kind of simple arithmetic, but you might be dealing with optimizing the volume of a box, the surface area of a box. There's different applications of optimization. So we're going to get into, in a little while, using the first derivative test, how it relates to the minima and the maxima. But let's go ahead and read and see if we can solve this problem here. So it says, of all numbers whose sum is 340, find the two that have the maximum product. That is, maximize q equal x times y. All right, q equal x times y, where x plus y equals 340. Okay, so we're looking at this very simple problem. What I'm going to first do is my second equation here, I'm going to get in terms of one single variable, and that is to say that y equal 340 minus x. And now I'm going to use this fact that y equals 340 minus x and replace it in the equation that I'm trying to maximize, in this case my product. So I will say then that q equals x times 340 minus x. And so I'm going to do this very simple algebra here of distribution, and I get 340x minus x squared. Well, in order to find the maximal product of these two numbers, I'm going to have to actually take the derivative so that I can perform the first derivative test. So this product that I call q, I will then take the derivative and say q prime. And so I end up with something that looks like this. The derivative of 340x is 340 minus and then 2x. Now, what I need to do is find the critical values for this function. So by doing that, I either need to know where it's equal to 0 or where it's undefined. But since we're dealing with a polynomial function here, we're only concerned then where it equals 0. So let's go ahead and write out that 340. Oh, by the way, I've got to set it equal to 0. That's what I was missing there. So I'm going to write out then that 340 then equals 2x, and I divide by both sides by 2, and I get the fact that x equals 170. But I'm not done, because I have to use the first derivative test to test the critical points, in this case 170, to make sure that it yields a maximal product. Well, if we have a local maximum, we know that the derivative has to go from positive to negative. So keep that in mind. So I'm going to write out 170, and I'm going to test some numbers before and after 170 into my first derivative function. So you can pick a number before 170. Let's assume like 0, for example. If you plug in 0 into this function, you get a positive number, a positive value. If you pick a number beyond 170, let's say like 200, and you again plug it in right there, well, you end up with a negative number. So the derivative q prime goes from positive to negative across 170. Therefore, this does yield a number that would give us the maximal product. So now that we know what x equals, I can go back and substitute it into the original equation back over here, and that is to say that 170 plus y equals 340. And so we subtract 170 from both sides, and then we get y equal 170. Okay, so in this case, x is 170 and y is 170, and that is the way to get the maximal product of two numbers. In this case, both of the numbers had to be the same. That might not necessarily be the case for all examples, but just something to keep in mind for this example. All right, let's take a look at one more problem here. Very similar. All right, so let me move this one out of the way. 1 second, adjust here. There we go. It says, of all numbers whose difference is 4, find the two that have the minimum product. So again, we can use this concept of the x and the y. So I can say then the product q equal xy, and it's very similar to the last problem. And the difference is 4. So we're going to say, well, x minus y should equal 4. All right. And so now we go about the same process, and we can solve again for y. And so suppose that I said y equals, all right, and what I'm going to do is say, well, x minus 4. So you just manipulate this little equation here, and you solve for y, and that's pretty easy. All right, I won't explain that in too much detail. But now you back substitute it into your q function, and you say x times x minus 4, okay? X times x minus 4, and then you carry out that simple distribution. You get x squared minus 4x. So this is the function then that we want to minimize in this case. And in order to do that, we take the derivative. And remember, once we find the critical values, we want to be able to go from negative to positive if it's a minimum. So we take the derivative, 2x minus 4. And we're going to set that equal to 0. And once we do that, we get 2x equals 4. And then finally, we can say then x equals 2 is our critical value. So we do our wiggle graph here for 2. All right. And if we plug in a number in here for x, okay, we're going to check numbers before and after 2. So say right here and right here. All right. And then we figure out that we go, in this case, from negative to positive. So in this case, it is minimal. All right. It is a minimum. So now that we know what x equals, we can go back and substitute it into the original equation. And we end up with something that looks like this. Y equal 2 minus 4, which is negative 2. So our values then, x equal 2 and y equal negative 2, will produce a difference of 4, but also have the minimal product. In this case, a minimal product of negative 4 when you multiply x times y. Okay, so not much to these problems. It's really all a big play on the first derivative test to determine minimum and maximum. And you can get more involved in these problems, and we will in a couple of examples later. But otherwise, it's generally not that bad. So, as always, I hope this video is helpful. And remember, like and subscribe.